I am Nirmala, Assistant Professor, Department of Computer Science, K.S.Rangasamy College of Arts and Science, Tiruchengode. So, today I am here to present a session on data structures and algorithms. So, I am not going to cover all the classifications of data structure, just I am focusing only on stack alone. So, before talking about the stack, I want to give some introduction about the data structure. So, these are the topics which we are going to focus on this particular session. So, basics of data structures, definition of stack, stack representation, then stack operations, applications of stack, then the important thing which we are going to see is infix to postfix conversion. As an introduction, data structure is nothing but it is a fundamental building block of a program. So, we use data structure for arranging the data in some order and we use that data for manipulating it. So, also we are using the data structure for developing efficient and effective algorithms. So, these are the classification of data structures. A data structure is classified into two common categories, that is primitive and non-primitive. So, primitive is nothing but it is the basic or built-in data types which may comes under the category, that is for example integer, character, float, boolean, then string. These are the data types which comes under primitive, whereas when we go for a non-primitive, it is again classified into linear and non-linear, whereas linear is nothing but the data will be stored in a sequence, and non-linear it is not under the order. Also we have some data structures in linear. Linear again splitted into static as well as dynamic. Array comes under static and linked list, stack, queue all comes under dynamic, whereas static is nothing but the value which is stored will be fixed size, as well as dynamic. In future if we want to add some more elements, we can go for dynamic type. Non-linear type will be having trees, graphs, tables, hash tables, etc. So, now we are moving to the stack. Stack is nothing but it is a linear data structure which stores all the elements in an order, which will be focusing on homogeneous data elements. Homogeneous is nothing but the data which is stored will be in same data will follow the same data type. So, that is stack will always store the data in linear order as well as the data will be in a homogeneous manner. Elements which are stored in the stack will be added or removed at only one end, that is called as top. The top pointer will be used for inserting an element or else to delete the element from the stack. So, stack is also called as LIFO. LIFO is nothing but last in first out. So, this is the example for stack. We have cafeteria trays, pennies will be arranged in a stack, as well as folded shirts will be arranged in an order, then shoe boxes will be arranged in an order. These are the examples of stack. So, next moving to the topic of representation, stack can be represented in two different ways. One is by using the array and another method is called as linked list, whereas stack using arrays will be in a fixed size. When we go for dynamic, then we are representing the stack in linked list. So, we give the example for stack with 4 elements. One is represented through array and the second method is by linked list. Stack operations. We have two basic operations, one is push and another one is pop. So, other than that we have top, then is empty, is full, then size of. So, push operation is used to insert a new element into the stack, whereas pop will be used for removing or deleting an element from the stack, where peek or top of will be used for retrieving the top element from the stack. Is empty and is full is used for checking whether the stack is full or whether the stack is empty. The final operation is called as size of. It retrieves or it returns the number of elements stored in the stack. So, this is a simple diagram which represents the stack operation push and pop. So, first stack is representing for push, that is inserting an element which is at the top, as well as the second stack will be used for popping the element. So, push operations will be focused only on adding an element which is used by the stack pointer called top. Before inserting an element into the stack, we have to check whether the stack is empty or not, whether it has a space or not. So, for if the stack is full, we cannot insert new element into the stack, then we may face a condition called stack overflow. If the stack is full, then the condition is called as stack overflow. If the stack is not full, then we can able to insert new element. So, with the help of the pointer top. So, this is the basic things we are going to perform in the stack. Main functionality of push operation is to add a new element to the stack, whereas the precondition and post condition. Precondition is nothing but before inserting an element into the stack, we have to focus whether the stack is full or not. If it is full, we may face a condition called overflow. Post condition is nothing but if we have space in the stack, then we may insert a new element into the stack without any errors. So, this is an example for a push operation. Initially, we are taking a stack with 4 elements A, B, C, D, and the top pointer will be pointing at the top element, that is D. Whereas, when we want to insert a new element called push of E, then the top pointer will be incremented after inserting a element. Similarly, the next next element is added likewise. Also, the top pointer will be incremented by 1. Next comes pop operation. Pop operation helps to remove an element from the stack, and here we want to check whether the stack is empty or not. If the stack is empty, we cannot able to delete element from the stack. So, if we are trying to delete an element or delete an empty stack, then we may face the problem called stack underflow. If the stack is underflow, we cannot delete. So, next comes pop operation. So, whenever we want to remove or delete an element from the stack, we perform pop operation. It helps to remove an element from the stack. So, before removing an element, we want to check whether the stack is empty. If the stack is empty, we cannot able to delete an element. So, we have to check whether the stack is empty or not. If the stack is empty and we are trying to delete an element, then we may face a problem called stack underflow. So, next, if the stack is full, then we can able to remove the element from the stack. So, these are the things we are going to perform on push pop operation. These are the functions we are going to perform on pop operation. Function is just removing an element from the stack. Precondition and post condition is there. Precondition, before removing an element, before trying to pop an element from the stack, we have to check whether the stack is empty or not. So, if the stack is not empty, then we can delete an element, that is the post condition. So, here is an example for pop. We take a stack of 5 to 6 elements. So, if we try to pop an element, then the topmost element in the stack, that is F is in the top, that is the element first to be get removed from the stack. So, next if we want to try the pop operation, the second element will be removed from the stack. Removing is nothing but just it will be staying there itself, but the top pointer alone get decremented by 1. Followed by that, peak operation is there. Peak operation is nothing but used for returning the top element from the stack. So, if we want to check whether there is a element available in the stack, so if it is not empty only, we can able to retrieve the top element. We want to check whether the stack is empty, the condition is top equal to -1. So, this is the example for retrieving the top element. So, here we have 4 elements in the stack. The top element is 40. When we perform peak operation, the top element 40 will be returned from the stack. Is empty operation. This is used for checking whether the stack is empty or not. If the stack is empty, this function will return the value as true. If it is not empty, then it will return the value as false. So, the condition is top equal to -1. So, here we have 2 different conditions of a stack. First stack will have 4 elements. If the condition is checked, is empty will return false because there is 4 elements in the stack. If the second stack is empty, then the result will be given as true. Followed by that is full operation. It returns true only if the stack is full, otherwise it will return false. The condition is top equal to capacity, total capacity -1, that is maximum size. So, here we have the same thing. So, here the first stack will have is having 4 is a maximum capacity. Now, the stack is full, then the condition will return true. If the second stack is having one more space, then it will return false. So, these are the applications of stack. So, function calls, then recursion, expression evaluation, syntax parsing. So, memory management, these are the applications of stack where we are applying stack. So, followed by that infix, postfix and prefix. Infix is nothing but the expression is given in an order, that is operand, operator and operand. Postfix is nothing but operand followed by postfix, operator postponed to the operand, as well as prefix is nothing but operator and operand. In this order only we are going to represent. These are the examples of infix and postfix alone. A plus B is infix expression, means then the postfix expression will be AB plus. So, just to see the examples which is given here. Then these are the procedure for conversion. So, whenever we are focusing on an expression, the evaluation will be started from left to right, scanning the given expression from left to right. So, here is the example for conversion of infix to postfix expression. The given expression is given here. So, first we have to scan one by one from the given expressions. So, each and every character will be scanned. If it is an operand, then it will be moved directly to the postfix string. If it is an operator, then it will be pushed on to the operator stack. So, based on the precedence, the operator will be pushed or popped from the stack. Finally, we get the output of the infix expression to postfix expression. So, thank you all for your patience of listening this session. So, in the next coming sessions, we will be seeing the evaluation of postfix expression.